Producers and distributors of Tech AV technical training material welcome you to this, the first program in the series on the subject of automatic process control systems. This program has been developed to assist operators and technicians who may be involved in the maintenance or control of production processes that utilize any form of automatic control of production variables. During the program, we shall explain the fundamentals of basic on-off controllers and then move on to overview a typical 3-unit controller as may be utilized with continuous processing methods. Modern production industries have come to depend upon safe and reliable control systems. Controllers are put in place to serve one primary purpose, and that is to ensure consistent quality or standards of finished products. Whether the operation is large or small, the accurate measurement and manipulation of many processing variables is the key to successful operations. Systems put in place to control these variables are generally known as automatic control systems, and this is what this program is going to explain to you. To help illustrate the working principles, let's imagine a small chemical company that produces a domestic cleansing agent which it then bottles and distributes on a local area basis. Their product is created using the so-called batch process, literally by making one batch at a time in a steam-heated vat or drum. First, the raw materials are placed into the vat and an agitator mixes them together. We call this homogenizing. The homogenized batch is then heated to a specific temperature to perform the blending process. The necessary heat required for blending is created in a small boiler, whence it is fed via a steam valve into a heating jacket which surrounds the vat. The steam control valve, featuring a remote-controlled actuator, is used to regulate the volume of steam flowing into the heating jacket. Now, here is the whole point of our explanation. Our blending process must be maintained at a steady temperature, which happens to be 80 degrees Celsius. An allowable limit of plus or minus 5 degrees is tolerated. But if the batch temperature moves anywhere outside of these limits, then the product will be off-spec and therefore worthless. In essence, the quality of the product is very much dependent upon the ability of the system to maintain the blending temperature within the specified limits. Let's see how this is done. A temperature sensor is positioned into the product. The sensor is connected electrically to a transmitter, which in turn operates the movement of a pointer against a graduated temperature scale. This we call the temperature indicator, which effectively provides an operator with a visual reference to the temperature within the processing batch. Sharing the temperature indicator scale on our model is another indicator, namely a set point indicator. This is an adjustable pointer, which for purposes of our explanation we shall adjust to align with 80 degrees Celsius, our desired blending temperature, or set point. A temperature recorder would usually be included in a control panel to provide a permanent temperature record. The set point indicator is connected to an electrical contact that in turn is connected to the steam valve controller. In effect, the valve is caused to open or close by the switching of the valve controller circuit. Now, when our process is first begun, the batch is cool and the temperature indicator is below the set point indicator. In this situation, the set point controller switches the steam valve to the open position. Steam enters the jacket and begins to heat the batch. As the temperature increases, the indicator rises, as detected via the sensor. When the temperature reaches the set point controller switches to the valve closed position. For a while, steam trapped in the jacket will cause a small temperature rise in the batch, which will be seen on the temperature indicator. The batch then begins to cool until such time as the temperature indicator falls slightly below set point. And again, the set point controller remakes the circuit to open the steam valve. The heating cycle repeats in this manner until blending has been completed. In our simplified example, the batch or product has been kept within the specified temperature limits using an on-off controller. All it did was to open or close what is known as the final control element, namely the steam valve. After the break, we'll see how the small company began to improve their production capacity and what problems they had to overcome.